So in today's slide, I'll explain. We'll formally start 8085 microprocessor, but before starting 8085 microprocessor, there are some very important terms which you should remember. Okay, so kindly have a look. Okay, so this is really very important part, and I will request everyone that you should keep a focus. Okay, otherwise, what will happen? You may lead to some issues. Okay, so look carefully. Okay. So if you look here, just a second, I'll just switch on my one device. One thing I have not accepted. Just a second, guys. Okay. So in today's class, we will first of all see some terms which are very important. Okay, before understanding 8085 microprocessor. So first thing which I hope you all might be knowing, that is the computers generally fall under two categories. One is called analog computer and other is called digital computer. Okay, so what could be the definition for both of them? Definition is again very simple. If you look carefully here, that a analog computer is that computer which is programmable in nature, and processing purpose it only accepts analog signal. That you have to keep in mind. Okay, now if I say regarding digital computer, so digital computer is also similar, only one difference is there, that is the processing part, whichever it will be doing, okay, the data on which it is going to process, that will be digital in nature. Okay, that is the only difference. Okay, so this small definition, I hope it's clear to everyone. So if I say what is analog computer and what is digital computer, this I am sure you all can answer me. Okay, just a small definition, and I'm sure you all can answer it if it comes in exam. Okay, so let's move forward now. Now let's see one more term, or before seeing that term, I would like to just have a small description regarding a computer. So in computer, these are the four sections which are very important, and I am sure that everyone might be aware of the definition of these four things. So I request every student just to read this. Okay, and I feel like that I don't have to explain. Okay, it's very simple. I mean, everyone is knowing about computers, so surely they might be knowing what is CPU, what is input device, what is memory, and what is output. If you are, I just request everyone to read this once and just confirm me that okay, sir, we know this. Just read once and just confirm me that you have a little bit idea or you are aware of these terms. Anyone? Yeah. So I also feel like it's not that big thing which I have to explain here. Okay, now let's move to the next important term, and that term is again very important. That is, what do you mean by microcomputer? Okay, so microcomputer is actually a computer which contain one microprocessor. Okay, and that will be considered as a CPU for that computer. Okay, so a microcomputer, I mean whatever laptop and all you have, CPU and all you have, they are actually referred as microcomputer. Keep that in mind. Okay, they are actually, the actual name for them is, they are microcomputers. Okay, so why they are called microcomputer? Because it contains one processor only. Okay, and that is referred as CPU, which everyone might be aware of. Okay, so if you look at the block diagram of a digital computer, you say, or a microcomputer, you say, the diagram is very simple, that in the center you will find microprocessor, which I am saying as CPU, and it will be connected with input device, output device, and memory. Okay, so if I say some examples, the examples will be like desktop computers, laptops, notebooks. Okay, so I'm pretty sure that this definition is also not that tough. I hope so. Okay, so I'll move forward. Next, let's see. The next term is, what is multiprocessor computer system? Okay, now what is multiprocessor? This is a again very important term, and maybe in exam you may get a question write down the difference between macrocomputer and multiprocessor computer. Okay, so you have to write in one or two sentences. Okay, so in my multiprocessor computer system, actually why it is called multiprocessor, because it contains more than one microprocessor. Okay, so if any computer which is having more than one microprocessor, it is actually called multiprocessor computer system. Okay, and examples will be, you might be aware of these examples like supercomputers and all. Okay, so supercomputers are those systems which contain more than one processor. Keep that in mind. Okay, so there is the difference is only based on the number of microprocessor it is having. Okay, so this I hope you are aware of. Okay, now this is a very important term, and I request everyone to listen this part because it's really very important. If you remember, in the last class I told you that the microprocessors have some bit size. They are also referred as 4-bit microprocessor, 8-bit, 16-bit, 32-bit, 64-bit. Do you remember this? I told you in the last class. Just tell me yes or no. Yeah, I hope everyone remember. Okay, I got it. And these numbers which you are seeing here, they are actually called word length. Okay, so this term I didn't told you that time because I had to specify in the next class. So I'm telling you now. So if I say a 4-bit microprocessor, so instead of saying 4-bit microprocessor, you can also say 4 word length microprocessor. Okay, so you say word length or you say 4-bit microprocessor, they means the same thing. Okay, even by the definition you can see here, a word length refers to the basic data size or bit size that can be processed by a processor. Okay, so what is word length actually? It is actually the data size or the bit size which a processor is capable of processing. And if you remember, I gave you an example that if it is a 4-bit microprocessor, it will be able to process 4-bit, it will be able to accept 4 bits of input. Okay, and after operation it can generate 4-bit of result or 8-bit of result. Okay, getting my point. Okay, so on this basis it is called as 4-bit microprocessor, or you can say 4 word length microprocessor. Okay, now let's see one more thing, that is some examples. If you say examples, already we have seen that is 4-bit microprocessor. So in your exam you may get question like this, like give me example of 8 word length microprocessor. Okay, so don't get confused. Whichever examples you referred in the last class, you have to write the same example. Only I have just replaced the word length word with the bit. That is the only difference. Okay, now this is a very important thing. Look very carefully. A processor of longer word length is more powerful and can process at a faster speed as compared to processor of shorter word length. Okay, and this is pretty obvious also. Yes or no? Because why I am saying, because suppose if you are having two processor, already you might be comparing also a 32-bit processor or a 64-bit processor, and I am sure before buying a laptop also you might be thinking, so which in market, suppose you have a 32-bit processor laptop and one you have 64-bit processor laptop. So intuitively you might be thinking that I should buy a 64-bit processor laptop. Why you might be thinking? Just because you feel that this will be processing at a higher speed, and you are actually correct. The reason is, if it is a 32-bit processor laptop, it can process only 32-bit of data at a time. Okay, whereas a 64-bit processor can process 64-bit of data at a time. Okay, so this you have to keep in mind. So that is really very important, that if you have a processor whose word length is more, it means it will surely be able to process at a higher data speed. Okay, at a higher speed as compared to the processor of shorter word length. Okay, now I request everyone to write this very important point. It can be a true false question. A processor of longer word length is more powerful than a processor of shorter word length. True or false? So this question may come in exam. So I already told in the last class also, if I say to write a question, please write down. Okay, because that question might come in the exam. Okay, so I hope this is clear to everyone. Tell me yes or no, this is clear. It's clear? Yeah. Okay. I'll move forward. Yeah. Okay. I'll move forward. Yeah. Yeah. Tell. Yeah. 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 Anyone is having any doubt? Yeah. Tell. Yeah. Yeah. You can speak. Yeah, yeah, okay, okay. So this is really very important question. I'll tell you. So if it is a 8-bit processor, it can process any data having from 1 bit to 8-bit. Okay, it can process like that. Okay, it's not like that. It can only process 8-bit of information. It can process any data whose word length is 1 bit, 2 bit, 4 bit, and 8-bit. Okay, is it clear now? Is this clear? I hope yes. Okay. Now I'll now move forward. And here it is. This is also very easy. I'm talking about the unit of memory, and smallest unit of memory is 0 and 1, because I'm talking about the binary. Okay. So you might have studied in first year also, that 4-bit is equal to 1 nibble, 8-bit is equal to 1 byte or 2 nibble. Yes or no? And you also might be aware of these simple formulas. So here I don't think I have to explain here. 1 kilobyte is equal to 2 to the power 10 bytes, or also equal to 1024 bytes. Okay, so this you have to learn by heart, and in your exam you may get question like this. I'm giving you as a homework also. Let me see whether you can find out later or not. The question is 8 gigabyte is equal to how many bits? This is a question. 8 gigabyte is equal to how many bits? So this kind of fill in the blanks question may come in exam. So I request you to find out the answer for this using the formulas which you are seeing here. Okay, so these formulas will help you. Okay, so this I mean you all are in a mechanical branch and you will deal with long formulas and all. I am sure that you will be able to solve this question yourself. Okay, so please write down this question, and these kind of questions may come in exam. Okay, so I hope everyone, yeah, no 8, I'm asking 1 C, actually 1 gigabyte is equal to 2 to the power 20 kilobyte. Okay, and 1 kilobyte is equal to 2 to the power 10 bytes, or 1024 bits. So you have to actually just multiply here. Okay, are you getting my point? So question can be anything. It can be like this also, like 8 GB is equal to how many nibble? This can also be a question. Getting my point? So you have to think carefully that what I have to fill here. Only these formulas only will help you out. You think carefully how you can do this. So first of all, you will find number of bits, and after that, what you will do, for one nibble, 4 bits are there. So you will divide with 4. That's you will get how many nibbles. Getting my point? Is this clear to everyone? So guys, give a try. If you're not able to, you can write in the Google Classroom, sir, I kindly explain. But I expect that as you are from a mechanical branch where a lot of maths goes on, this simple unitary method question you can solve out yourself. Okay, so let's proceed now. Okay, now this is from the exam perspective I have kept here, that is evolution of microprocessor. In this you are requested to remember these many microprocessor names and their properties. Okay, this much property you have to remember. 3 properties, that is what is the word length, what is the memory capacity, and how many pins that microprocessor is having. For example, if it is a 8085 microprocessor, for this you have to remember, that's for sure. You cannot say that, sir, I don't know about 8085. This you have to remember. Others also you have to remember for exam purpose. So 8085 is actually having a word length of 8-bit. It is capable of interfacing with 64 kilobyte of memory, and it has 40 pins. So in last class, what I found out, that few students were saying, sir, what is the meaning of pins? I'm not getting. Okay, So I'll just show you what is the actually meaning of pins. So actually pins means this. Look here, all of you. So if you look carefully, this what you are seeing here, this is actually pins. Okay, this whatever you are seeing here. And in 8085, total 40 pins are there. This is the, you can say, pin diagram of 8085. I have shown also here the pin diagram of 8085. So in 8085, the IC which you will see, it will be having 40 pins. While completing the fourth module, we will be dealing practically. Okay, there, if you, I mean, by the end of fourth unit, if you are coming to college, we will be having, we will be in lab also, and in the lab, what you will find out that you will be actually seeing some, I mean, pins. I mean, some. What I'm trying to say is microprocessors, and these microprocessors will be having pins. Okay, so the pins will be 40 in number. Okay, that you have to keep in mind. So just to I mean, solve your curiosity of what do you mean by pins, that I am showing you here. Okay, now let's move towards. So I request everyone that please, for the exam purpose, please remember this. Okay, I hope you can do that. Yeah, okay, now I'll move forward, and this was a very basic slide. Now I'll move towards a new PPT where I will specifically speak about 8085 microprocessor. Okay, so here we are going to deal with 8085 microprocessor. This you have to keep in mind. Okay, now first of all we will see features of 8085 microprocessor. Okay, so if you look at features, what does it mean? It means that what are the benefits that microprocessor is having. Okay, or you can say what are the I mean, capabilities that microprocessor is having. Okay, so we will see one by one, and I am 100% sure that you will not understand everything, because it's difficult to understand in one day. So I just promise you one thing, that in coming 1 week you will understand all the features. Okay, so if you are not understanding in 1 week, then you can tell me once more, and I will try my best to explain each and every feature once again, no problem. Okay, so today you have to just get an idea. Okay, these all features we will be using one after the other every day. Okay, so let's see one by one. Okay, so first feature, so let's look at the first feature. And first feature, already you might be knowing little bit, that is, it is a 8-bit microprocessor. So what will be the word length? Can anyone tell me what will be the word length? 8, correct. So if if it is a 8-bit microprocessor, the word length is 8. Okay, so if word length is 8, you can also keep in mind, if word length is 8, the data bus will also be that many bits only. Keep that in mind. Okay, so what is data bus and all, we'll understand after few slides. Okay, just to keep in mind, in microprocessor, in 8-bit microprocessor 8085, it is having something called as data bus. Okay, and that data bus size is 8-bit. Okay, and it can perform operations on data whose maximum size is 8-bit. In order to understand this, I will do one thing. I will draw a diagram which can elaborate better. Okay, so you look at microprocessor, and if you remember, a microprocessor had 4 main parts. One was ALU, one was register, control unit, and what was the fourth part? Can anyone tell me? System bus. Yeah, correct. Yes, I got it. Okay, so this is your system bus. Okay, and with system bus only you are connecting the peripheral devices. Okay, so in system bus only we have something called data bus. Okay, and in data bus, if it is written here 8-bit, it means there will be 8 channels. 1 2 3 4 5 6 7 8. So there will be 8 channels, and every channel will be capable of 0 and 1. Okay, these channel will be capable of sending or receiving 0 or 1. Keep this in mind. One channel can only send one data, and that data will be either 0 or 1. Keep that in mind. Okay, so where is data bus? So you can say data bus is present inside system bus. Okay, so this much I hope is clear to everyone. Just tell me yes or no. Yeah, Okay. So I hope you got the meaning of what is Databus, why it is 8-bit, that you will understand later on, don't worry. But for intuitive purpose, I can say if it is a 8-bit microprocessor, generally the Databus is also of 8-bit. Okay, so this much you can understand from this. Now let's see the next point. The 8085 along with Databus, it is also having address bus. Okay, and address bus is also inside system bus. Okay, so if I say system bus is equal to address bus plus data bus plus one more bus is there, that I'll tell you, just wait for some time. So in system bus there are three kinds of buses. Okay, address bus, data bus and one more bus. Okay, data bus in 8085 is of 8-bit, means there will be 8 wires. Okay, and address bus is of 16-bit. What does it mean then? It will be having how many wires? 16, correct. There will be 16 wires, and every wire will be capable of carrying 0 or 1. I am telling 0 or 1 means at a time it can carry either 0 or 1. Okay, so this point should be clear to everyone. Okay, now let's move forward to the next point in that, and the next point says the maximum address memory capacity of processor for 8085 is 64 kilobyte. Okay, so if you are not getting this, I'll give you try to make you understand with an example. Suppose I have a microprocessor whose name is X. Okay, and it is having a address bus which is of 2-bit. So if I say address bus of 2-bit means there will be 2 wires, yes or no? Okay, so if there are 2 wires and every wire can either give me 0 or 1, so I can make a truth table like this. Let it be wire number 1 and let this be wire number 2. What all combination I can get? Both wire can give me 0, or I can get this combination, or I can get this combination, or I can get this combination. I hope you will not get any other combination other than this. Yes or no? So what I am trying to say is, if you look carefully, these all combinations are unique ones. Okay, and these unique combination is actually called address. Okay, this unique combination is actually called address. And you might be knowing what is that. If I say define address, you will tell something unique all over the world. Something, if it is unique, then that can be referred as address. Okay, so from that point of view, I am telling that this is actually an address. Okay, so if you are getting this, what I am trying to say, how mathematically I came to know. So if you look carefully in this system, how many address I am having? Can anyone tell me how many unique address I have? 4 unique address. Yeah. So it is based on a formula. The formula is, if number of wires is n, the number of unique address will be 2 to the power n. Yeah, so based on that formula, if you look here, you will be understanding. Okay, so now I hope everyone might have understood. Just tell me yes or no. If you tell no, then I'll repeat once more. Everyone has understood? Yes? Yeah, okay, fine. Yeah, okay, now I'll move forward. Next is there anyone who has not understood? I hope. Yeah, tell me. Yeah. Means in 8085 there is 8-bit data bus and 16-bit address bus. Now you don't ask me, sir, why it is 16-bit. Then I'll ask you why you have 2 eyes. Okay, why I am saying, because it depends upon the developer that what kind of size of memory it wants to interface. Based on that, they will keep the address bus and data bus. Okay, got the point? Okay, so it is based on that. So I'll also give you a better answer, as you are not aware of those terms. So I'm not explaining you in great detail. Otherwise, it will be like a very complex situation, and you will tell, sir, please explain this later on. So I'm not explaining now. Okay. we will be having some kind of questions and all. There I'll explain you in better way that why we are having a 16-bit address bus and why we are having a 8-bit address bus. Okay, that I'll explain you later on why. So for why, you can write down that question, we will explain later, we'll understand later. Okay, now next is that address memory in 8085 is ranging from this one to this one. Okay, now how this is ranging from this one, you can understand from the example we have taken. So we had a 2-bit microprocessor. So what was the address? Its address was 00, 01, 10 and 11. Yes or no? So if I say what is the range of this memory, you will say the starting is 00 and ending is 11. Yes or no? Yes or no? I hope yes. Yeah. Similarly, suppose this is a 2-bit microprocessor. Instead of that, suppose if I am having a 16-bit microprocessor, it means it will be starting from the starting address will be this one. The starting address will be this one, means 16 zeros, and what will be the ending address? 16 ones. Okay, so this will be the ending address. Okay, and if you write in this, I have written in binary. If you write in hexadecimal, it will be represented like this. Okay, means 4 ones is referred as F. If anyone is knowing a binary to hexadecimal conversion, they might be knowing 4 ones is equal to F. Okay, and at the end you have to add a letter H. So H represents hexadecimal and this 4F represents the number in hexadecimal format. Okay, so the range will be 0000H to FFFFH. So this range is clear to everyone or not? Just tell me yes or no. Yes. Okay, so I will erase. Yeah, range means address. This is actually address number 1. Okay, and this is your last address. In the middle you can have lot many addresses and total number of address will be this much. Okay, this is address number 1. This is address number 65536. In middle you will be having many more addresses. Okay, got the point now? And at this address you will find some information that will come later on. Okay, is this clear to everyone? Yes or no? Okay, I'll move forward now. Yeah, next. This already we cleared that 8085 is having how many pins? 40 pins. And it is fabricated based on a technology that is called NMOS technology. So please remember this. This may come as a test on which technology 8085 microprocessor is made. So NMOS technology. Don't go in detail what is NMOS technology, how it works and all that is actually completely purely electronic subject. Next 2 points. Please don't forget for some time. This we will understand later on. Just remember 8085 is having something called as program counter and the length of program counter is 16-bit. Length, there is something called stack pointer and length of stack pointer is 16-bit. What is the meaning of program counter, what is the meaning of stack pointer, that I'll explain you, and why it is having 16-bit, that also I'll explain you. So for time being you forget. Okay, let's see the next point. So the next point is again important and this I'll explain you now only. The next point is saying that microprocessor 8085 is having 6 8-bit registers. Okay, how many registers? 6 8-bit registers. So if I again draw the block diagram of microprocessor, you are actually knowing that it contains ALU, it contains control unit and it contains registers. I hope you remember this, yes or no? So I am talking about these registers only. Okay, so in 8085 there are how many registers? 6 registers. Okay, and their names are B, C, D, E, H, L. अभी राजू राम ये सब नाम नहीं दे सकते हैं, but these are technical names. Okay, B, C, D, E, H, L. Okay, so these are the technical names. Okay, and generally this B, C, D, E and H, L are in pairs. Okay, So that's why it's written here. It is arranged in pairs. Okay. So there are 6 registers which you can use individually also. But if you want to use in pairs, you have to use in this format only. Okay. Means I cannot pair B register with E register. Okay. So if you have to pair, B can be paired with E and E can be paired with D. Okay. This you have to keep in mind. Okay. Now it is written here 8-bit register. 8-bit register means what? It is something like this. 8-bit register means there will be a block where you will find 8 spaces, and inside these 8 spaces only what you can do, you can store zeros and ones like this. Okay, getting my point? So 8-bit register means what? One 8-bit register can store 8 bit of information. Got the point now? What is the meaning of 8-bit register? So 8-bit register is a register which can store 8 unique information. Am I clear now? I hope I am clear. Yeah, and keep in mind, in one block you can keep only 0 or 1. Okay, it's not like that you are keeping like this. You cannot do like this. So see, this is wrong. Okay, this is wrong. I am writing here RONG, wrong. Means in one bit you cannot keep both. Either you keep 1 or you keep 0. That you have to keep in mind. Okay. So I hope everyone has understood what is the meaning of 6 registers and what is the meaning of 8-bit registers. Okay, let's move forward now. This microprocessor is working on the power supply of plus 5 volt. If you give more than this, then there is a problem. If you get less than this, there is a problem. If you give power supply less than this, it will not work. If you give more than this, it may burn. Okay. So keep that in mind. You cannot give power supply more than this and less than this. So it is operating voltage is 5 volt. Okay. Now look at the next point. The next point is it contains a clock frequency of 3 megahertz. If you remember, while explaining the definition of microprocessor, I have said that it is clock driven. Do you remember? Can anyone tell me? Do you remember that term, clock driven? Yeah, okay. So clock driven, even if you remember, I have drawn like this a clock. Yes or no? Okay, and actually one high pulse and one low pulse is called one clock. Okay, so this much is called one clock. Okay, so this is your second clock from here to here. From here to here, third clock. Okay, so here I can show you 3 clock pulse. Okay. So in 8085 microprocessor, it is working on a clock frequency of 3 megahertz. Now what is the meaning of 3 megahertz? Let's understand. 1 megahertz is equal to 10 to the power 6 clock pulse in 1 second. I hope this small formula you can remember. 1 megahertz is equal to 10 to the power 6 clock pulse in 1 second. Means like these pulses, 10 to the power 6 pulses will pass in 1 second. Getting my point? I hope this point is clear to everyone. Repeat. I am repeating. Okay. So if you just see this first, 1 megahertz is equal to 10 to the power 6 clock pulse per second. And what is clock pulse? I have already shown you the clock pulse. See here, this is your clock pulse. Okay, 1 clock pulse, 2nd clock pulse, 3rd clock pulse. Okay, 1 high and 1 low. I mean, if I draw here, this is 1 clock pulse. Okay, now again from here till here, this is 2nd clock pulse. Okay, so this is 1 clock pulse. From here to here, this is 2nd clock pulse. Okay, so what I am trying to say, in your microprocessor, it is actually working on 3 megahertz clock pulse. Means 3 into 10 to the power 6 clock pulse in 1 second. Okay, means these many clock pulses will pass in 1 second, and on these clock pulses you can execute instructions. Okay, so what is actually the use of clock pulse? These clock pulse is used to execute instructions. Keep that in mind. We will understand later on, don't worry. Just for time being, you remember that the microprocessor 8085 is capable of executing 3 into 10 to the power 6 clock pulse in 1 second. This much you can remember, I hope so, yes? Tell me yes or no. Okay, let's move forward. The last point, the last feature, don't remember, just keep in mind there is 80 basic instruction and 246 opcode. This we will discuss later on. So I hope now I can say that everyone is, wherever I am making a tick mark, everyone is knowing that, and wherever I am making a cross mark, you are not knowing that. Am I correct or not? Just confirm me yes or no. Yeah, okay, I'll move forward now. Yeah, okay. Next slide. Now the next topic is bus organization. So what is the meaning of bus organization? Let's understand what is the meaning of bus first. So if you remember, I told you there is Databus, AddressBus, and there is one more bus. So first of all, let's see what is the meaning of bus. Okay, so what is bus actually? Bus is a group of conducting wires which carry information. Okay, and all the peripheral devices, okay, I'm telling again, all the peripheral devices are connected with microprocessor through this bus only. Okay, or you can say system bus. Okay, you say system bus or you say bus, it means the same thing. Okay, so you can say that with the help of system bus only all the peripheral devices are connected. So there are actually 3 kinds of buses. So already you were knowing 2, now I am telling you all the 3. So these are the 3 buses: address bus, data bus, and control bus. So inside your system bus, you will find address bus, you will find data bus, and you will also find what? Control bus. Okay, so what we will do, we will try to understand first of all that what these buses are. Okay, maybe we will not be able to complete this today, but we will surely be able to complete by tomorrow, I mean next class. Okay, so we will not go in very high speed that you don't understand. Okay, so I'll try my pace in such a way that you should understand everything. Okay, so let's now understand what is the meaning of address bus, data bus, and control bus. Okay, so let's see one by one. Now I request everyone to read this first. I request everyone to read this, at least first point. I request everyone, I'm giving you 30 seconds time, just read this. So I hope everyone has read first point. Yeah, okay. Now let's understand what is address bus in detail. So if you look carefully, what is address bus? It is a conducting wire which carry what? Address only. Address only, nothing else. Okay, it carries address only. Next, it is unidirectional in nature. Unidirectional in nature means only one direction. I will draw the diagram to make you understand. So every time I have to draw the block diagram only. Okay, so thoda wrong ho gaya. Okay, let's see. So this is your ALU, this is your register, this is your control unit. As it is boss, so I am giving more space to control unit. Now what is address bus? Address bus are conducting wires and it is a part of system bus and it carries address only and it is unidirectional in nature. Let's understand what is the meaning of unidirectional. So if I say peripheral devices, we have memory, we have input device, and we have output device. Okay, and these all devices, what they are actually having. So see guys, please try to understand what I am trying to say you. What do you mean by memory? Can anyone tell me? What do you mean by memory? Memory means storage. Okay. Memory means memory means storage space. So I'm trying to give you a very technical point. Just try to listen. Okay, So you are saying storage. Okay, so storage means data, yes or no? What you are actually storing? You are actually storing data, yes or no? Yeah. So storage means, yeah, storage means there will be some data, and that data will be stored at some address, yes or no? Tell me. Yes. So what is memory actually? Yeah, what is memory actually? Memory is actually a group of addresses, and at every address you will find some data, yes or no? Okay. Similarly, your input device, what? It will be having some address, and at that address you will find some input data. Okay, at that address you will find some input data. Similarly, output device, it will be having some address, and at that address you can have to pass some output data. Getting my point? So all the peripheral devices whichever you are looking, they will be having something called as address, and at that address you will find some kind of data. Okay, so what I am trying to make you understand is all the peripheral devices are having addresses. Okay, that I wanted to say. Okay, so what actually your processor will do, it will use address bus, to point out to a specific address, so that from there data can be taken out through the data bus. Am I clear? Please, I am repeating the sentence once more. Okay, listen very carefully. I am saying, what is address bus? Address bus are unidirectional bus which will always be pointing from processor to outside, so that it can point to a specific address, and at that address you will find what? You will find data, and with the help of data bus I can bring that data. Now it is clear? These two terms are clear, address bus and data bus? I hope yes. Okay, so I hope, yeah, I hope it is clear. So that is the reason why the address bus are unidirectional in nature and always points from, you can see here also, it always one direction, it points from microprocessor to memory or microprocessor to input output device. Okay, so this you have to keep in mind. Okay, this is very completely a logical thing. Okay, because if processor has to connect with any device, it has to first of all find out the address, and after getting the address it can pick that data from there. Okay, and address bus is only responsible for finding that address, and that address will be always pointed in this way only. Okay, next, if you look carefully, next point is already clear to everyone, that as it is a 16-bit type, so the range will be this one. This already we have understood. So I request everyone to just confirm me whether you have understood or not. Is it understood? Yeah. Okay, now I just want you to read what is data bus, so that I can explain you properly. I want everyone to read it properly first. What is data bus? I request everyone to read this point and this point also. Okay, so I assume you have read the first point at least. Okay, I'll move forward. So what is data bus? Already I gave you a bit of idea, but I'll tell once more. Data bus is a conducting wire which carries data only. It is bidirectional in nature. Bidirectional means what? I'll draw the diagram again and show you. If this is your processor, okay, and if this is memory, suppose at a specific address we have some data. Okay, so from processor the data can, from memory the data can come here, and also from processor data can go to this space. Okay, means both way moving is allowed. Okay, so that's why it is called bidirectional in nature. Okay, and even you can see I have written here, from microprocessor to memory or IO device, and from memory or IO devices to microprocessor. Okay, both way. Okay, is this clear to everyone? Yeah. So, and last point is already clear because it is a 8-bit type. So surely the range will be 00 to 00. I mean 00H to FFH. Yes or no? Yeah. Okay. So I will now move forward and let's understand third thing, that is control bus. Okay, now control bus is actually not having a specific kind of channels. Okay, because there, I mean, depending upon the type of signal, it may use two bus, I mean 2 wire, or it may use 3 wire or 4 wire or 6 wire. It doesn't, I mean, it is not fixed actually. Okay, so it's not said like it is having these many wires. Okay, so for timing you can keep in mind that control bus are conducting wires. I mean, a number of wire is not specified. It is actually used to generate timing and control signal. Okay, timing and control signal to control the complete work. Okay, that is the meaning of control bus. Okay, and generally there are 5 kinds of control signals. Okay, a control signal means actually what I'll tell you. I'll again draw the block diagram to make you understand. Just have a look. So suppose if this is your microprocessor, and in this you have control unit, ALU and register, and suppose this is your memory. I'm making a memory like this. Suppose this is your input device and suppose this is your output device. Now if suppose the processor wants to get some information from here. Okay, so getting information here means the control unit has to pass a signal that is called memory read signal. Okay, means if a processor wants to read an information from memory, that is, then for doing that task control unit has to pass a signal that is called memory read signal. If processor wants to write something in some space, some information, then that is called memory write signal. Okay, in the same way, if processor wants to interact with a IO device, okay, then that will be called as IO read signal, or it may be called as IO write signal. And the last one for timing you forget, we'll understand later on because it is very complex. I'll explain you later on. So I just wanted to make you understand only one thing, that is these kind of signals are there, and this is actually called control signals, and control bus is responsible for delivering these kind of signals. So I request that, I feel that you might have understood. Okay, now if you have understood, what I will do is quickly I'll show you a very interesting diagram where you will see all the buses together. Okay. So I'll not move forward. In the next class we will try to understand this complete structure. Okay, I'll explain you in detail. Okay, and I will do one more thing. I'll go in, I'll explain with a video also in that class. Okay, so next class is again very important. I request you guys to be present in the next class, because there you will actually understand how address bus is sending address, how data bus is receiving data, and what is the job of control bus. Am I clear now? I'll explain with an example. Okay, so with this I am stopping the class for today, and I hope I have tried my best to explain each and every topic. If anyone is having still any doubt, you can do one thing, you can put a query in the chat box.